Hello everyone, welcome back to Let's Talk Tech. We are in the third video of our LangChain tutorial series, and in this video we are going to learn about chaining. So chains are sequence or operations that link together multiple tasks or step in a process. LangChain uses chain to manage workflow, and LangChain has one thing, it's really beautiful. It's called LCEL, LangChain Expression Language, and let's learn about it further. So in this video, we'll cover three things: simple chain or simple sequential chain. The second thing is parallel chaining, and the third thing is branch chaining. So let's go one by one and let's learn one by one. So first of all, the first thing is simple chain or simple sequential chain. So how does it work? We have seen it in our previous video, and if you have not watched it, please go and watch our previous video so that you have a gist about how does it work. So first of all, we have a prompt. What we do is we will provide this prompt to a particular model or an LLM, large language model, and which provides us output, not a very structured output. It will contain AI message. It will contain tokens, number of tokens, metadata, and many different things. And then what we did is we passed it into string output parser to get a proper curated output. Here's a simple example of how simple sequential chain works. First of all, sequential, from the name itself, you can understand that it's simple and it goes in a series. So first of all, we have this prompt, and then we have our large language model, which goes into this chain. And then we have a parser, that is string output parser. So that's how simple sequential chain works. The next thing we would be talking about is parallel chaining. So how parallel chaining actually works. So in parallel chaining, there are multiple individual tasks which runs in parallel. So for example, here we have a chain, a simple sequential chain. So what we can see is we have four simple sequential chain here. First is this one, and this, and this. So we have four simple sequential chain, and it all starts with this one, and then it goes to these three different simple chains, and we have a final output out of these three different chains, and all these processes are running behind individually at the same time. So let's go to our code and see how does it happen exactly in LangChain. So here we have our code ready so that we don't waste further time, and let's see what's going on here. So let me explain you about this code. What I have done here is, here we have a prompt which will generate you coding question based on particular topic, let's say arrays or recursion, or you want questions on linked list, anything. And then we have three different chains. First chain will solve the question in Python, second chain will solve the question in Java, and third chain will solve the question in C. And so here you can see our first prompt template, that is, you are a coding instructor and human will provide a message, generate a coding question on the topic of something. The question should be challenging but solvable. And then we have three different templates, that is for Python, Java, and C. And in each of these you have, you are a Python expert, or you are a Java expert, or you are a C programming expert, and you need to solve this particular coding problem in this particular programming language. And now let's move forward and see how does this chain actually works. So first of all, what we have is the first chain. Let's move back to presentation. First of all, we'll design our very first chain, first basic chain. That is, we will take our first prompt, we'll put it into model, we'll get a string output, and then we will pass that particular output to each of these simple sequential chain in parallel. So let's see how do we do that using runnables parallel. Coming back to code, so we can see here that we have defined a chain where simply what we were doing is we'll put this prompt template which is right here, and then we'll pass it into some large language model. I have used llama 3.370 billion parameter spec model here, and then we'll get a string output out of it, and it's clear and simple. And what I have mentioned is runnable parallel. So runnable parallel is a part of LCEL, LangChain expression language, and it helps in running different tasks in parallel or running different runnables in parallel. Runnable lambda is simply just a piece of task, just like how we are defining this chain here, and similarly it's done here. We'll come to it in a few minutes. Let's see this particular chain first. So in this runnable parallel there are three branches. First is Python, second is Java, and third is C. And then we'll pass the same thing into another runnable lambda. And what is this? Lambda AX combine something something. Let's not think much of it. Let's go beyond and see what's here. Python, and then it will direct you to Python branch chain, and it's right here. So let's see how runnable lambda actually works. First of all, we can see this lambda x. It's nothing but input. So we have some input. Then we have analyze Python. That's a function right here in which we are giving this x. So we have an input. We'll put that input in this function, and then we will pass it into our model simply like normal chains, and then we'll get output. To make it a proper structured output, we'll pass it into string output parser. That's what we have done all the time. Don't confuse much with the words runnable lambda and runnable parallel. Simply runnable lambda is a nothing but piece of task. Runnable parallel is a part of LCEL which helps in running these tasks parallelly. One more thing is we can't pass this same chat prompt template in runnable lambda, but what we do is we format that prompt. So here we have our chat prompt template, and then we, instead of invoking it, what we do is we'll do this format prompt, and where features is equal to feature, and feature is nothing but topic of that particular question, and that's it. That's how we have our Python branch chain, Java branch chain, and C branch chain. Simple. Now let's come back to runnable parallel. We have three branches, and in each of these branch we have these three chains. Let's go back to the diagram and we can understand it properly. Till this everything was clear, and then runnable parallel came into role. What it does is there were three branches. So this is the first branch, this is the second branch, and then this is the third branch. First branch was about Python, second branch Java, and then third branch C. And now in each of these branch, as we have seen in runnable lambda, that there will be a prompt in format, and then it will be passed into an LLM, and then it will be passed into string output parser, and we'll get one output from each of these chains. Coming back, now we have done and we know about how runnable lambda and runnable parallel works, but this chain does not end here. We have something another in this part, and that is another runnable lambda, and we have one input x that is output from all these three branches. And what we do, there's another function called combine. So let's go and see what this function is about. It's nothing but output, how we print output of each of these coding language. So what we do is in this x we'll go to branches, and if first of all we'll put input of Python chain, that will be a Python code, and then we'll put input of Java chain, and then we will put input of C chain, and that's how we will return Python, and then we'll write that code, we'll leave few space, and then Java will write that code, leave few spaces, and then C programming, and it will write that code. So here we have our question. It is maximum subarray of some function. The topic was array. I've given array as topic. So first we'll see this in Python, the solution in Python, and next it will move to Java. Yep, Java is right here, and then it will be in C. Yeah, it's right here. And yeah, that's how parallel branch chaining, and that's how parallel chaining works. Simple, simplified, nothing to worry about. The next thing we'll be talking about is branch chaining, and let's move back towards our presentation to see how it works. Here, as we can see, the diagram is quite similar to parallel chaining, but there are few changes like this case 1, case 2, and case 3. There's no final output linked to all the three chains, and then there's this classification chain. So let's see what happens in this particular situation. We have our first prompt, and that is our classification prompt, and the first chain itself is a classification chain, and based on the classified output it will move towards the particular case. Let's say answer goes in the direction of case 1 or case 2 or case 3 based on the classification output, and that's how it will work. So it's more of a sequential chain. It will, the direction is sequential, it won't run parallelly, but it will depend on the case. I hope you're acquainted with Python programming. So just how we use switch case, and similarly the classification chain will lead towards one of the multiple chains available in the branches, and it's a very simple branch chaining. It may go more complex that each of different chains have different branches, but let's take a simple example and let's simplify things. So coming back to our code, in this particular code what we are doing is we will give some inputs or feedbacks, and based on that feedback the chain will classify if it is a if it is a positive feedback, if it is a neutral feedback, or if it is a negative feedback, or if it needs to be escalated towards a human agent. So based on that, let's see how it works. First of all, we'll be having our main prompt template, which is not in the top but right here. That is our classification template, and that is, you're a helpful assistant, and human will say classify the sentiment of this feedback as positive, negative, neutral, or escalate. And then we will have these four branch template or four branch chains template, that is positive feedback template, negative feedback template, neural feedback template, and then escalate feedback template. Simply as generate a thank you note for this positive feedback, generate a response addressing this negative feedback, generate a request for more details of this neutral feedback, and then generate a message to escalate this feedback to a human agent. So let's see how this chain basically works. The first part of the chain will be same as we will be calling the classification prompt, and let's see that. So yeah, first we'll call that classification chain. We have different classification chain here. Template, model, string output parser, nothing complex, simple as it is. And then in the next chain, what we have done is we have this classification chain, which is right here. And then we have the another thing is branches and nothing else. What is it? So let's go to branches to know more about it. And here we have runnable branch. Just like runnable parallels, runnable branch is another thing in LCL which helps in selecting the particular branch. So yes, what we have here is we have our classification chain. It will classify the output as positive, negative, neutral, or escalate, and then that output we will put it in this particular branch, runnable branch. If the output is positive, it will trigger positive feedback chain, simple chain. Positive feedback we'll call model, and then we'll get string output parser. Another thing will be lambda. If it is x is negative, it will call this negative feedback chain, and if it is neutral, it will call this neutral feedback chain, or otherwise it will call escalate feedback template or escalate feedback chain. And that's how it works. So here we have few good, bad, neutral reviews. Let's go with good review and let's run this. The review is: the product is excellent, I really enjoyed using it and found it very helpful. And here's a possible thank you note: dear customer, we are thrilled to hear that you had such a good positive experience with our product. And that's it for this video. If you have any doubt, please comment it below. And if you liked this video, please like the video, share it with your friends, and subscribe to our channels Let's Talk Tech. And we'll be talking about RAG in the next video, so stay tuned and hit the bell notification button so that you get updated as soon as the video get posted. And thank you. Bye bye.